In this video, we are going to talk about hydrogen bonding and how it contributes to wonderful properties of water that is so essential for life. So we've learned about a number of chemical bonds. We learned about ionic bonds, and it is based on atoms either receiving or donating electrons. We learned about covalent bonds, which involves sharing electrons. One thing we didn't talk about is hydrogen bonds. So what are hydrogen bonds? Hydrogen bonds are, compared to ionic and covalent bonds, are weaker bonds, and they're transient. Hydrogen bonds, as the name implies, happens between a hydrogen atom that has a partial positive charge and another atom that has partial negative charge or even a complete charge. So it's an electrostatic interaction. It's an interaction between two opposite charges. But the hydrogen bonds are, as I mentioned, are weak, and they're also transient. That's why hydrogen bonds are usually shown with this sort of non-continuous line, because they're constantly forming and bonding. And because of that, they are considered weaker bonds. Now, on their own, hydrogen bonds really don't contribute to binding of molecules with one another in isolation. But when you have a whole lot of them, they do make a lot of difference. And it is hydrogen bonding between water molecules that give water really interesting and important properties. So in here, we're looking at a number of water molecules. So if we start with this one, this water molecule, we remember that the bond between oxygen and hydrogen is polar. So the oxygen on this water molecule has a partial negative charge, and the neighboring water molecules have, in addition to this one, but the neighboring water molecules are facing their hydrogen atoms that have partial positive charge towards this molecule. Now, you can see that you got two water molecules forming with the same one down here, and this can happen because these bonds keep breaking and forming. So it breaks a bond with this one, it breaks, and then goes to this one. And this formation of hydrogen bonds between water molecule leads to formation of a huge network of water molecules that hydrogen bond with one another and kind of transiently, if you like, hold hands. So just for your own practice, draw a water molecule and try to see if you can reproduce this one from memory, and then check your work next to this image. And now answer this quiz and come to discussion and check your answer. So let's talk about water's life-supporting properties. Now, all living organisms require water. Actually, a large part of what our Earth is made of is water. And cells consist of about 66% water. So water plays an important role and a major role in life. Now, the question is, how does it contribute to sustainability of life? So now we're going to talk about different properties of life, and one of them is surface tension. So this is a simulation of, let's say, water molecules in a body of water, and at any one point, water molecules that are floating in the water are being subject to bonding between other water molecules that are there from all over the place. So they are subject to hydrogen bonding and whatever's out here. So they're being pulled from all sorts of directions. But when you look at the surface of water, you see that the forces that we're exerting from the top on these water molecules are not existent anymore. So they're not being pulled up, and they're bonding, hydrogen bonding with other molecules that are down here. And not only that, on the surface of the water, on the surface of the body of water, there is hydrogen bonding between water molecules right on the edge. And that kind of, if you think of it as an analogy, are people who are forming chains, holding their hands one after another and forming a body chain. So that would be kind of an analogy to this one. And that's leads to a high surface tension for water. So what is surface tension? Surface tension is a measure of how difficult it is to break through a surface. And different liquids have different amounts of surface tension. That means it takes different amounts of force to break through them, and water is a liquid that has really high surface tension. And that is because of this chain of water molecules that are lying across here and then are pulling each other and holding each other. That's why this is the surface tension also is a basis of formation of drops. It also provides opportunities for organisms like these bugs to be able to survive on water and maybe either stand on water or walk on water and find food. Now, surface tension is one of the reasons that you really shouldn't do belly flops. And that's why belly flops hurt so much, because you have to really, when you hit the water, you're being resisted by the surface tension of water that doesn't want to let you break this surface. And that's one of the reasons that it really hurts when you do belly flops. Now, a couple of other concepts that are relevant are cohesion and adhesion. Cohesion is a tendency of molecules that are of the same kind to stick together. And we just learned in the surface tension how water molecules like to stick together. So that basically answers this question. Cohesion is much stronger for water than other liquids. And what is the basis of staying stronger together? Is because of those hydrogen bonding between water molecules. Now, this cohesion is a property of water that is really important for plants to survive, to be able to take water from the root and deliver it to the rest of the plant. Another concept is adhesion, meaning when the tendency of two different kinds of molecules to stick together. And molecules that are able to hydrogen bond with molecules of water tend to adhere really nicely to water. So adhesion is another property of water that again helps life and plants in particular. So when we look at a plant life, what happens is this plant really grows and really separates itself over time from the ground. So getting water from the soil, it becomes a challenge. Now, plants have openings on their leaves, which is shown blown up in here, stomata they're called. They have openings on their leaves and they continuously lose water. Water is evaporated through these openings. At the same time, water is traveling from the root and going into these highways that delivers water to the rest of the plant. Now, since water molecules have cohesion, you can think of them as holding their hands. When water molecules evaporate and leave the surface of the plant up, because of those cohesion, they're going to pull these water molecules up with them. So as these water molecules go up, these waters from the bottom are going to be pulled up. So that's the importance of cohesion. But what about adhesion? Well, one of the ways that water is actually able to crawl up and actually be able to travel through the stem of the leaf is the ability of water molecules to hydrogen bond with these cellulose molecules that are what plants are made of. So adhesion between water molecules and the body of the plant allows water to kind of, you can think of it as a suction cup. If you can, I don't know if you've ever seen the Mission Impossible movie by Tom Cruise. One of the things he does in order to climb a window, he uses suction cups. So you can think of this as kind of form of a suction cup for water to really hydrogen bond and climb up this route as the water molecules that are evaporating are pulling it up. So plants really dependent on these two important properties of water, which is a result of hydrogen bonding, either between water molecules or between water molecules and the components of the plant. Now, water has an interesting property, is that when it freezes, its density decreases. Normally, in a liquid water, hydrogen bonds constantly break and form and break and form. And this allows water molecules to move around and stay liquid. But as you decrease the temperature, the hydrogen bonds don't break as much, and these water molecules don't have as much kinetic energy to be able to move around. So therefore, at some point, at the freezing point of water, then water molecules become frozen in space and form crystals. And these crystals are the basis of those beautiful snowflakes that you may have seen. So therefore, not only they make crystals, these crystals, because they have a lower density compared to liquid water, then they tend to stay on the top, like in here. And this is important for life, because in really areas of the world which is really cold, the top level of the oceans and lakes freeze. But that freezing helps insulate the remainder of the lake from the really freezing harsh conditions that are outside of the water. And this helps organisms that live in these bodies of water to survive. So that's another way, an interesting property of water helps life. Water also stabilizes temperature. So what does that mean? What is temperature anyway? Temperature is a measure of motion or kinetic energy of molecules. The higher the temperature, the more kinetic energy is going to be happening. But because of hydrogen bonding, the temperature is going to have to go up much higher before water molecules can move around. So therefore, water can withstand increases of temperature much better than other liquids. So if you, let's say, compare two different liquids, let's say alcohol and water, you're going to have to heat up water a lot more before you can raise its temperature as compared to alcohol. So this is called heat capacity. Heat capacity measures the amount of heat that is required to increase the temperature of a liquid by 1 degree. Now, again, if you compare water and, let's say, another liquid that is alcohol, or another liquid in which there's not as much hydrogen bonding, you're going to need a lot more heat to increase the temperature of water by 1 degree as compared to something like alcohol. So water has a high heat capacity. It takes a lot more heat in order to raise its temperature. Water also has a high heat of vaporization. So what is heat of vaporization? It's the amount of heat that is required to allow the molecule to escape from a state of liquid to gas. Now, when substances absorb heat, their average speed increases, and at a certain point, they are able to escape as a gas. Now, water, compared to other liquids, just such as alcohol, they have a high heat of vaporization. You have to heat them a lot more than something like alcohol before they can evaporate. And this is a very important property of water that helps us with evaporative cooling. When we exercise, our bodies get hot, and one of the ways that our bodies help us remain a constant temperature to keep the homeostasis of temperature in our bodies is by sweating. Because water has a high heat capacity, and it also has a large heat vaporization, what it does when we perspire, that water is going to want to escape into the open air. But before it's going to do that, it needs a lot of heat. Where does it get the heat from? It gets it from our bodies. So that's why the high heat capacity of water and its high heat of vaporization allows us to cool down, because it takes away all that heat that is coming out of our body and it escapes into the atmosphere. Water's high heat capacity also plays an important role in allow us to survive in that environment in which global warming is an issue. We are constantly breaking records, heat records on Earth, because of our use of fossil fuels, which has led to melting of glaciers and snow covers. Temperature over land is going up, and temperatures, everything is going up, and then also water evaporates more, so we have more humidity in the air. These are some consequences of global warming. But things would have been a lot worse if we didn't have these large bodies of water, because a lot of the heat that is generated right now because of global warming is being absorbed by the oceans and the bodies of water. If it wasn't for them, we would have been much hotter. Now, who's paying the price for that? Well, eventually we are, and we will. But then the sea creatures who have been evolved to live in a particular temperature, as we warm the world and the water absorbs the heat, the ocean heat content increases. And then that's bad for them. That's why a lot of coral reefs around the world are basically called bleaching, because an excessive heat causes them to basically die. Okay, we mentioned that water is polar. That means it has partial positive charges and partial negative charges, and that allows it to interact and hydrogen bond with molecules that are polar or charged. Now, on the other hand, water does not really mix with oil. Water mixes really nicely and interacts really nicely with molecules that have a charge or are polar, but when it comes to non-polar molecules, it just does not interact with them, which is the basis of the concept of being hydrophobic and hydrophilic. So hydrophilic, philic in this case means love. So these are water loving, and these are hydrophobic. This hydrophobic means water fearing. So oil is hydrophobic. Now they don't really fear water. It's just the chemical properties of water and oil or non-polar molecules that they just cannot be mixed. They just don't interact. So it's not a love-hate relationship. It's just their chemical properties. On the other hand, molecules that can interact with water are hydrophilic. And another way of saying molecules that interact with water, it's another way of saying they dissolve in water. We dissolve things in water all the time, like sugar and salt and a lot of things in real life. So why can we dissolve sugar and salt in water? Because they're hydrophilic, because they can form hydrogen bonds with water. Now, water is an excellent solvent for hydrophilic molecules. Why? Because hydrophilic molecules, as I mentioned, are either polar or they have charges or partial charges. So the reason we can dissolve salt, sodium chloride, in water is because when we add sodium chloride to water. The partial positive charges on the hydrogen atoms on water interact with the negatively charged chloride ion, and the partially negative charged oxygen molecules are going to interact with positively charged sodium ions. So that's for sodium chloride. But for example, for something like sugar has a lot of polar bonds as well. So the water hydrogen bonds with the polar bonds in sugar molecules. Which brings us to the concept of solution. A solution is consisting of a uniform mixture of two or more substances. And usually when we're talking about life, all solutions of life are water-based. Now, a solution is made up of two things. It is made up of solvent and solute. And the dissolving agent, which is usually present at a higher proportion, is solvent. And in life systems, the solvent is water. And a substance that is dissolved is the solute. So as I mentioned, all of life's solutions are everything in our bodies, in the oceans, in nature. Everything is water-based, which we call aqueous solutions. So all solutions in life are aqueous, meaning they're water-based. The solvent is water. So we already talked about salt water and sugar water. In biological systems, again, water is the solvent. When you put a solvent and solute together, you get a solution. So think about these two questions, see if you can answer them, and then come to discussion and check your answers.